Uniform circular motion can be described as the motion of an object in a circle at a constant speed. As an object moves in a circle, it is constantly changing its direction. At all instances, the object is moving tangent to the circle. What do you think will happen if the satellite does not change direction, or it is not constantly changing its direction? It will go out of its course and it won't be able to scout around Earth, but it will just go in space in a straight line and make crash in an asteroid if ever that will happen. That motion's net force is said to be inward or centripetal force. The time t it takes to complete a full revolution is called as the period, denoted by the unit of second per revolution. And frequency was known as the number of revolution per time, denoted the value of f, and as a unit of revolution per second. Now, the first formula for UCM, or uniform circular motion, is getting the velocity, which is v is equals to 2 pi r over t. And the formula using the frequency is velocity is equal to 2 pi r multiplied by the frequency. This is the main formula to be used in circular motion problem. We can just simply derive this just in case the other variables are missing. The second formula is getting the acceleration, which is using the formula a is equal to velocity squared over r, where r is the radius of the circle. And here are some sample problems. A satellite to be set in geosynchronous orbit if it rotates around the Earth once every day. For the Earth, all satellites in geosynchronous orbit must rotate at a distance of 4.23 times 10 to the 7th power meters from the Earth's center. What is the magnitude of that acceleration felt by a geosynchronous satellite? To get the acceleration, you need to get the velocity first. But wait, the t or period isn't given. To find t, you must use what is in the problem, like 1 day equals to revolution. Convert that to seconds per revolution to come up to an answer 86,400 seconds per revolution. Then substitute it to the formula of v. Thus, substitute again to the formula a is equals to v squared over r to acquire this answer. Note: do not round up while you are still not done solving to get a more accurate answer, and final answer should be in the right amount of significant figures to get the best answer. To relate the Newton's law to UCM, we use the formula v squared over r from the UCM to acquire with the formula of force is equals to mass velocity squared over radius. In case 1, in finding the tension of a cord connected to a ball while moving it in a circular motion, given the formula, tension is equal to mass velocity squared over r. Case 2 is an object making a turn in a flat road. Why do you think the object is not going out of its path? It is because of friction. To find the velocity of or the v minimum of the object, for it not to go out of course, given by the formula square root of coefficient of static friction times gravity times the radius. And case 3 is an object making a turn in a tilted road. It is just like case 2, but we need to account for the angle. The formula is the centrifugal force is equal to mv squared over r, or n sine theta is equal to the mass times velocity squared over radius. And the velocity minimum is equals to the square root of the radius times gravity tangent theta. In case 4 is when a person is leaning on a wall and you are like spinning inside the rotor. The formula is F net is equals to mv squared over r, or net force is equals to mv squared over r. And to find the v minimum is equal to square root of the radius times gravity divided by mu of S, which is this coefficient of static friction. And the case 5, in a roller coaster loop-the-loop, the weight and net force are equal. The formula is weight is equal to mv squared over r, and the v minimum is equal to square root of radius times gravity. And here are the sample problems.
A car is making a sharp turn uphill. The hill is said to have a circular path with a radius of 15 meters, and the road is also tilted at an angle of 78.55 degrees. What should be the velocity of the car for it not to go off course? Now, please take a pause and try to solve this problem yourself. For the solution, to find the V minimum, it is the square root of the radius times the gravity times the tangent of the given angle, meaning the square root of 15 times 9.8 times tangent of 78.55. So the answer will be the square root of 1.470, and the square root of 1.470 is 1.2 meters per second. That is the velocity needed for the car not to go off course. What is the radius of the loop-de-loop of a roller coaster if the cart is 50 kilograms and the cart is moving at 100 meters per second squared? So, again, take a pause and try to solve this yourself. And also, analyze the question before try to answering it. Now, in order to solve this problem, we need to use the formula in case 5, and the formula is the square root of radius times gravity is equals to the minimum velocity. So how will we get the radius? We just need to square both sides to remove the square root and then divide it by the given gravity, meaning r is equals to 100 divided by 9.8, and the answer will be 10 meters.